What is periodic tables? Periodic table is a chart that shows all known chemical elements. It's arranged element based on atomic number and similar chemical properties. Periodic table was created by John Newlands, Johann W. Dobereiner, Dmitry Mendeleev, and Henry Moseley. The origin of the periodic tables. In the early 19th century, scientists such as Johann Dobereiner introduced the idea of triads, where elements with similar properties were grouped in threes. Later, in 1864, Johann Newland proposed the law of octave, stating that the properties of element repeats every X element when arranged by atomic mass. In 1869, Dmitry Mendeleev successfully arranged elements according to their atomic mass and chemical properties. His periodic table was remarkable because he left gap for undiscovered elements and accurately predict their properties. And last, in 1913, Henry Moseley discovered that elements should be arranged by atomic number instead of atomic mass. This discovery corrected early mistakes and led to the modern periodic tables.
Elements in periodic table. Group means the vertical column up and down in the table. There are 18 groups in total. Atoms have the same number of valence. Group 1 is alkali metals. They are highly reactive and soft metal that forms alkaline solutions. Group 2 is alkaline earth metals. They are less reactive than group 1. They have 2 valence electrons. For elements in group 3 to 12, they are hard and strong. The melting and boiling points are high. They can also form colored compounds. They show a transition in properties in between highly reactive metals and less reactive metals. The period in periodic table is the horizontal row in periodic table. There are 7 periods in total. Period number is the same as number of electron shells.
In the periodic table, elements are arranged into vertical columns known as group. Do you think they have their own each name? For the first column, which is group 1, they are called alkali metals. They are also very reactive. Group 1 elements are soft metals with low density and float on the surface of water. These alkali metals also have a grey shiny surface at room temperature. Let's move on to group 2. They are called alkaline earth metals. They are reactive but less than group 1. This group consists of 6 reactive metallic elements that all have 2 electrons in their outermost shell. Next, we have group 3 until 12. These elements are called transition metals. They are hard, strong and dense metals with a shiny appearance. And then we have group 17. These groups are called halogens. Group 17 elements are known as halogens and exist as diatomic molecules. For the last column, which is group 18, they are called noble gas. Noble gases are chemically unreactive due to valence shells that are fully filled with electrons. Next, we have electron valence. What is electron valence? Electron valence is the electrons in an atom's outermost shell called valence shell. It is the one that determines its chemical behavior. The number of valence electrons will determine the position of the group of an element.
Periodic table trends. Basically, how different properties change when you move across the periodic table or down a group. Sounds complicated, but actually it's just a pattern. Type of trends. So there are a few main trends we are always study: atomic radius, ionization energy, electronegativity, and reactivity for metals and nonmetals. Okay, first, atomic radius. Atomic radius is basically the size of an atom. So across a period from left to right, the radius gets smaller because the nucleus becomes more positive and pulls the electrons closer. But when we go down a group, radius get bigger because there are more electron shell. Second, ionization energy. Ionization energy is the energy needed to remove an electron from an atom. Across the period, ionization energy increases because the electrons are held tighter by the nucleus. Down the group, ionization energy decreases because electrons are further away and easier to remove. Next, electronegativity. Electronegativity is how strongly an atom attracts electrons when bonding. Across the period, electronegativity increases because the atoms are smaller and the nucleus is stronger. Down the group, electronegativity decreases because the atoms are bigger and electrons are far from the nucleus. Lastly, reactivity. Reactivity depends on whether the element is metal or non-metal. For metals, being reactive means losing electrons. So when we go down the group, metal lose electrons easier, so they become more reactive. For non-metals, reactivity means gaining electrons. So when we go up the group, non-metals become more reactive.
Trends are matter because we can predict reactivity, predict bonding, and understand element behavior.
So, in conclusion, periodic trends allow us to predict the chemical behavior of elements. Across a period, atomic radius decreases while ionization energy and electronegativity increases. Down a group, atomic radius increase while ionization energy and electronegativity decrease. Additionally, metals become more reactive down the group, whereas non-metal become more reactive up the group. Understanding this pattern are essential for explaining bonding, reactivity, and chemical properties in general.
That's the end of our presentation. Thank you.
Sodium for salty times,
magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, then argon,
potassium,
and calcium, so you'll grow